Hi everybody! In our previous video we talked about how you could use function notation with equations, but it turns out you can also use function equation with graphs. So let's take a look at a few examples. If I said graph the following lines and your equation said f of x equals 3x minus 2, all you need to remember is that f of x is the same thing as y. So in this equation, the m would be 3 and the b would be negative 2. This means that I would begin on the negative 2, and then I like to write in 3 over 1 so that I remember to go up 3 and over 1. Rise 3, run 1. I could also go backwards and go down 3 and left 1. Then when I'm finished, I would just graph my line. Similarly, in problem number 2, I would have a slope of negative 1/2 and a y-intercept of 6. The f of x is just another name for y, so it doesn't change the way I graph this line. So I would start on positive 6, and then I would go down 1, right 2, down 1, right 2, down 1, right 2, and then I would graph my line. Another way we could use function notation is to find values on a graph. So if f of x is graphed, so I've already given you a graph here, find the following. The first one says find f of negative 4. Whenever a number is inside of the parentheses, I know that that is an x value. Now on a graph, an x value is the steps that we take to the left and the right. So f of negative 4 means I took 4 steps to the left. So I'm looking at this line on the graph right here. What I need to do now is I need to look for a point on the graph that touches that line. If I find this point right here, which is where this graph touches the pink line, the y value of that point would be 2. So my answer here would be 2, because that point is on the second floor of the graph. To figure out what happens for f of 0, I need to remember that 0 is an x value, which means I didn't take any steps. We always talk about steps going in and out of the elevator. I was already in the elevator. Now the graph crosses that line right here. The y value, or the floor that I'm on at that point, would be 0. For f of 2, I'm looking for an x value of 2, which means I took 2 steps into the elevator, so I'm on this line. The point on the graph that's on that line would be right here, which is down 2 floors. So my answer would be negative 2. Finally, f of negative 5 means I took 5 steps to the left to get into the elevator, because that's an x value. So we're talking about this line over here. That point is again on 0 for the floor of the building. For the next one, we're going to change things up a little bit. So in this one, it says f of x equals 0. When a number is on the outside like this, not inside the parentheses, that's a y value. Now, y values are the floors of the building. So a y value of 0 means I'm on the 0 floor. If I look for where the graph touches the 0 floor, that actually happens in 2 spots. When I have 5 steps to the left, and when I didn't move at all. So I went 1, 2, 3, 4, 5 steps and I landed there, and I went 0 steps and landed there. So there would actually be 2 answers. When x is negative 5, I'm on the 0 floor, and when x is 0, I'm on the 0 floor. For number 8, again, this is a y value because it's outside of the parentheses. So I'm going to look down 2 floors down here. The only place where the graph is on the lower second floor is when x is a positive 2. And finally, f of x equals 4 means that my y value is a positive 4, which is 1, 2, 3, 4 right up here. The only level of the graph at positive 4 is this point right here, which would be when x is negative 2. Lastly, we're going to look at some application questions. Now, these are very typical of a test like the SAT test or the ACT test, both of which you're probably going to take at some point. So it's good to understand what these questions might look like. If f of t gives the number of fish in a pond at any time t, where t is measured in days, then what does f of 3 equals 8 mean? It tells me in this problem that t is measured in days, and t is also whatever's inside the parentheses. So this number right here must be t, which is 3 days. Now it tells me that I'm getting the number of fish in a pond. So the output of this function is going to tell me the number of fish. In other words, this means that there were 8 fish on day 3, or on the third day. Another example would be if d of t gives the distance a car has traveled at any time t, where t is measured in hours. So again, they're telling me t is measured in hours, t is what's inside here. Then which of the following best describes the meaning of, this should actually be a d, I apologize for the typo, d of 4 equals 100. Well, since the 4 is inside the parentheses, just like the t, and the t is the time measured in hours, it must be 4 hours. It also tells me that I'm measuring the distance the car has traveled. So the 100 must be the distance the car has traveled. Now, the first option here says the car traveled 100 miles in 4 days. Since I'm measuring my time in hours, I can eliminate that option right away. The car traveled 4 miles in 100 days. 4 is the number of hours, so this is out because this says it's 4 miles. The car traveled 100 miles in 4 hours. Well, that seems to make sense. 4 hours and the 100 miles is the distance. Let's just double check that part D doesn't make any sense either. The car traveled 4 miles in 100 hours. Again, 4 is the number of hours, so since this says miles, that's out. That narrows it down so that C must be the correct answer. All right, thank you guys so much for watching. I hope you have a wonderful afternoon, and I will see you for some practice.